the actual inclusion of multiple radios to provide robust solution is in fact well demonstrated. And so what we're doing is leading the way here in the United States to say, the radios don't matter, let's just put them all in the box. If you're going to put a radio up in the box in the street, let's put up all the radios.
Yeah, and then we can get, as you say, get the functionality more quickly and actually, move towards these use cases where we are saving lives, which is primarily what this is about, isn't it?
That is correct. In other words, putting the radio up on the pole doesn't do anything except put a radio up on the pole. It's delivery of the applications that counts. Now, this is, again, there's an interesting development here in the United States on the automotive side, where the automotive trade associations have joined together to create a new trade association called Automotive Innovators. And they're working together with the Infrastructure Trade Association, which is NEMA, the National Electrical Manufacturers Association, and I happen to be chair of the transportation section within NEMA. And so what's really exciting is, for the first time, the automotive companies and the infrastructure companies are coming together to say, let's get beyond the business of the radio argument, and let's just get on with the business of developing and deploying applications. And so there's not only this move afoot on the infrastructure side, there's also this move afoot on the automotive side to say, let's deliver these applications. And the low-hanging fruit is red light running, the business of preventing a car from running through a red light. That's quite straightforward to achieve. It's low-hanging fruit. Let's do some of those applications and get them done.
And you can achieve this, as we have said before, through DSRC or CV2X. But that is a use case as well that could be achieved with V2N. So actually using the existing mobile network, that would be successful and low latency enough. We're talking about a latency on the network of below 300 milliseconds, I think you said.
Yes, that's correct. So we've shown consistently that the latency over the network is less than 300 milliseconds. So when you're talking about a vehicle approaching a traffic intersection, that's plenty of low latency to be able to deliver a red light running warning in the vehicle, or apply the brakes, or whatever the automotive company decides to do with the warning. But the big advantage that it gives you the coverage by using the network of around the corner or over the hill. And it also allows you to see, quote unquote, the intersection when the intersection is obscured by the truck in front of you, and so forth. So one of the things that we've found in practice, there are applications that need short-range radios, primarily for redundancy. And one of the things we use, the short-range radios of the various types, like DSRC or CV2X Direct, is for paramedics approaching the intersection when they want to reliably turn the light green for themselves and bring everybody safely to a halt. We find that additional reliability in those kind of use cases is achieved with the network communication as well as the direct communication. So we see that there's use cases and applications for both. But for example, here in the United States, school zones, the business of slowing vehicles down when the children are getting on and off the school buses, is a big application for connected vehicles. So you want to know that the yellow light is flashing, or it's the time when the children are getting on and off the bus. Now there's no latency requirement at all. We just need to know that we're in the school zone and the flasher is on. A minute's latency is probably fine. And so in those, adopting cellular V2N as part of the solution really allows us to deliver all sorts of applications immediately. and because there are many, many applications, even some of the reference applications that we first started with is a dangerous curve. Now, a dangerous curve is always there. Doesn't need a short-range radio to tell you that there's a dangerous curve. It's not moving anywhere. So many of these applications are variable speed limits, for example, and so on and so forth. And the Dutch have done a lot of work in this regard with their talking traffics, where they're delivering all sorts of applications, V2I, the infrastructure talking to the vehicles through the cellular network. So it's a key part of the puzzle and allows us to get to delivering these applications just much sooner than waiting for the whole build out of the infrastructure with a short-range radio.